All right, well, it's 12 o'clock Eastern time, so we're going to go ahead and get started. So welcome and thank you for joining the Irrigation Association's 2022 Agriculture Faculty Academy, which is sponsored by both Rainbird and Senator. I'm Noreen Rich, and I will be facilitating today's session. So before we dive into our session, though, I did want to cover a few housekeeping items today. So let me go over here, click this. There we go. So the housekeeping items are going to be that today's session is being recorded and will be shared with registrants post-event. So please keep an eye on your inbox. We're anticipating sending those out next week sometime. So just keep an eye out for those. Secondly, we have muted everybody by default, so we won't be disrupted by any latecomers. So please keep your microphone muted throughout the presentation, unless you have a question for our speaker, as this will help minimize any sort of background noise. Third, during the presentation, if you do have questions, you can ask verbally by taking yourself off mute. There's also a raise your hand feature, which you can use. And then you can also submit them via the chat box, which I will be monitoring throughout the session. So don't be shy, feel free to get your questions in. We'll try to get them asked and answered kind of right around the time you submit them. So please use the chat box and our raise hand feature. Lastly, we do want to encourage interactivity, so feel free to have your video on for this session and to use the chat box to introduce yourself and maybe where you teach at, just to kind of create a little bit of rapport with your fellow colleagues here. So without further ado, please welcome our speaker, Xin Chao, who's going to be doing the Internet of Things, Edge Computing and Deep Learning in Agriculture. So I'm going to go ahead and stop sharing my screen, and if you would like to start sharing yours, that would be great, Xin.
Thank you, Noreen. Start sharing my screen. Yeah. Okay. Can you guys see my screen okay?
Yep, I can see it. Okay. Yep, and you sound good too, so I think you're good to go.
All right, I think you have some other people entering in the waiting room, so just so you know.
We'll keep an eye on it and kind of bring them in as we go along, so.
Sounds good. Well, thanks again. Really appreciate the opportunity to speak with you today about some of the work we have been working on in the last 2 or 3 years. I have to be honest, I'm quite nervous to present this topic. I have an agriculture engineering background, especially in irrigation management. I'm not a computer scientist, so if any terminology or definitions or something's wrong, please feel free to correct me and discuss from there. So as we all know, there's more data available to the ag industry, probably to agriculture during our life. In your house, there are more things that are digitized, like your thermostat, doorbells, all kinds of things. Same thing is happening to agriculture. Whether it's for production or whether it's for a storage purpose or later transportation process. So mainly because there are more sensors, and also we have more options for different kinds of telemetries. We have some really high-speed telemetries like 5G. We also have some lower speed telemetry is available, but very economically sustainable for agricultural use, like LoRaWAN or NB-IoT or some of the IoT side of telemetries. So I wanted to go through a few concepts with you first, and again, feel pretty nervous to present about this. This is how I try to understand these concepts when I started in this area. So the first thing is I want to cover is Internet of Things, especially the telemetry side of that. You probably can even argue whether you want to dash between Internet of Things or no dash. So again, I think it's an open topic. But on the telemetry side, if you think 5G as a high-speed internet, if we put analogy, think about 5G as a highway, when you enter a downtown area of a big city, you can house more cars. There are more lanes on either side, but normally the distance is quite short. And then if we think about IoT, telemetry, those are much lower capacity and much lower speed, but you will see that everywhere for long distance uses. So that's why IoT might be a great candidate for agricultural monitoring or environmental monitoring. The next concept is cloud computing. I just Googled it, and this is what shows up. I think it's a credible source from Microsoft. Feel free to read about that. But my understanding is you will have all your data stored on the cloud. You will process your data and on the cloud, over the cloud, or at your server, and then provide that process results to your clientele. Next one is deep learning. So again, this is a definition I referred from IBM. Basically, it's an algorithm trying to simulate the behavior of human brain. And I'll show you some of the thoughts I have when it comes to deep learning, maybe the advantages and the disadvantages, based on the examples I have encountered. Next one is edge computing. So edge computing, my understanding is that you will try to process that data close to where it's sourced or where it's collected. And then you will send that packaged or processed data results through telemetry to your cloud or to your server. So we have all those fancy concepts, and we have all the tools, we have all the sensors, we have all the telemetries. The question, those are just tools, right? But how does that help agriculture, and what does that look like? So I'm thinking about this picture I found online, and maybe it would simulate some of the feelings some growers are having right now. There are so many tools and so many sensors available, but how much can that really help growers to make a decision and have that return of interest? I think that's a key. So I think there's still a very long way to go. So next, I would like to talk about how we approach the data-based agriculture through a on-farm research, extension, and education network. But before I do that, I wanted to just to give you an overview of the agriculture background here in the Nebraska Panhandle. So I'm stationed in western Nebraska. I'm in Mountain Time Zone. I'm about 3 hours away from Denver. And over here, this is where I am. It's a semi-arid climate. We have much less rainfall compared to our eastern colleagues. Soil is mainly sandy or sandy loam soil. And there are some places it has silt, higher silt content. The irrigated majority crop over here are dryland crop, and majority are actually rangeland. Beef is a pretty important industry in Nebraska. The same thing in the Panhandle. The irrigated crop we have here are mainly sugar beet, dry edible beans, corn, alfalfa, potato, and wheat. We're definitely huskers, but we're also very proud of the unique crops we have in the Nebraska Panhandle, which is sugar beet and dry edible beans. And we have few dryland crop here as well, mainly sunflower, peas, wheat, and proso-millet. The water source we have here, there are mainly two water sources. One is groundwater. It is limited. Normally there is an allocation put on a 5-year period. Also, we heavily rely on surface water supplies from canals and from the mountains, from Rocky Mountains at Colorado and Wyoming. Those surface water supplies can be unstable from year to year. there's a lot of challenges to grow crops in the Nebraska Panhandle, and this probably stretches to everywhere, to every producer in the US or to the whole world. There are different issues we're facing, but it is pretty challenging probably everywhere. So just speaking from my experience in the Panhandle, this picture shows you a surface water canal delivers water to growers' fields. In the background over here, you will see the Scottsbluff National Monument. So this is a press release from one of our irrigation districts. They regulate the surface water delivery. They also take care of the cleaning of those laterals. This was a letter, I think it was sent in May. Basically, it's saying because the water supply is allocated, they strong encourage producer to conserve water, and the rationale is if you conserve, it is first come and first serve. So if you have a senior water rights, you can use as use as many as you want, but the downside is that you have a total allocation. So if you use it up, the duration of water supply will be shortened. There were cases that the canal were running dry in middle of August when corn and sugar beet are still growing, and even dry edible beans are still growing. So definitely conserving water, that's a real issue, and that would help stretch the duration of the water supply, even for surface water users. Also, Mother Nature in Western Nebraska is not very forgiving neither. On the left picture, we are famous for the high wind. So a couple of weeks ago, this was a picture I shot just outside my home. I think this is a fairly new center pivot. We're reaching really high wind speed, and maybe the center pivot was not parked in the right angle. So it was tipped over. And on the right-hand side, this was a picture I took at my research plot. We basically get few hills every year. Normally, it's not a big issue, but in 2019, that was a total wipeout. The size might not look very big, but it's a wind speed. Again, it was 65 to 70 miles per hour with a size like that. So it's like a bunch of coins shredding, almost like a blender, blending all your crop. Normally, we would harvest dry edible beans around 50 bushel per acre. And that year I was able to get 5 bushel per acre. So some of the challenges. Starting from 2020, we developed a data-based research, extension, and education on-farm network. For every product, and probably now people like to give it a good name. So we named it Nebraska Panhandle Learning Agricultural Network, short for PLAN. So the core of PLAN is data and interaction. On the data side, there are a few sources of data we're trying to capture. One is from different kinds of sensors. It could be commercially available sensors like soil moisture sensors, temperature and relative humidity sensors. There are also some sensors we develop on our own when we realize, oh, we have a need, but there's nothing available commercially. And we also try to capture different farming processes, like the planting, when they plant, when they tillage, and what kind of tillage they do, and what's their rotation, what's a fertilizer or herbicide applications. The third point is human observations. Just like a crop consultant, when they go to the field, they probably will make some hand notes, and we are also trying to capture that kind of observations as well. The rationale to capture all these types of data is really, it's not, because agriculture, that's a whole system. It's a holistic system. You really can't just think about only irrigation, even I'm an irrigation management specialist, have to consider the whole picture and interaction of one to the other. So the data we collect here, we're trying to treat every farm as a treatment. So in that way, we're trying to compare so the holistic management and historical management approaches, those are a treatment for that farm field. And then we are trying to compare farm field A to farm field B and see if we can learn anything from that. And there are 4 E's. That's I think that our principle. The first E is we want this network to be very engaging. We want it to be very useful to the stakeholders and industries and engage them in the design process and the evaluation process. The second thing is enhancing. We wanted to not just collecting data for research use, but we care more about how the growers are going to use the data and how they want us to package or process that data. The third thing is because it's an on-farm network, nothing is perfect at the very beginning. So we wanted to keep evolving our software and hardware over time. The last one is this is the learning process. So throughout the process, we are hoping to provide some value to the growers. We also want growers to kind of see what's each other doing. Well, it's kind of like you're seeing your neighbor is irrigating or doing something. At the very end, maybe he has a higher yield or lower yield, and you start to wonder why. And so through this network, we're providing the data and all the other things we're capturing during the process. So when they discuss why your yield is lower or higher, there is some data they can base on to support their hypothesis. And we also wanted to learn from growers. There's a lot of things we don't know. I'm at a research and extension center. The research we do here probably very similarly to every research and extension center. Those are much smaller plot scale, and there are things you can't replicate. So that's just an overview. This is a framework of plan, and it starts from sensors, and we use LoRaWAN mainly right now. We also start to use cellular. This part, it doesn't matter that much. Whichever signal is the strongest and cheapest, we'll use that. And then the data will be sending into the server, and it'll be running our algorithms, and there will be the visualization platform. And then I will not go into details in this, but there is interactions between growers and UNL extension specialists or educators. So, like I said, main data, almost 90% of our data right now are transmitted over LoRaWAN. This is one of the available IoT telemetry technologies. It has it's very slow, has a maximum data rate of 50 kbps, and we chose that because it's really easy for you to set up a private gateway. So that when we start, we used a private gateway. This is one example. We put that gateway at the start location. This is at a grower's home. We really appreciate the grower. He let us use one of his structure at his home so we can set it up. And we install sensors and his fields around his home. And the furthest field, there are some topography here, but the furthest field was about 4 miles away. Data was very steady, and we were very happy with it. But starting in 2021, it is really hard to set up private gateways, find structures and all that. So starting from 2021 and also this year, we worked very closely with the IoT network provider, Page Wireless in Nebraska. Really appreciate their help. So we're using their network so we can reach more growers. I think Page Wireless right now has a full LoRa coverage in Nebraska and maybe even in several other neighbor states. So this is, we started from 6 fields. That was the launch year of this network. After we kind of figured out everything and we hit COVID, it was pretty difficult to follow the regulation of the university and also working with the growers because you're going to need that face-to-face interaction to figure out some of the details. So we had 6 fields covered about 1,000 acres, and we use a private gateway. In 2021, we grew to 23 fields, and we started to use the signal from Page Wireless. It was much more easier. So these are the field sizes, individual field sizes participating in plan. You will see the biggest field we have is over 300 acres. I think it's a half of a section. And the smallest field we have is 13 acres. So I really like this plot because I think we are covering growers in different scale and maybe in different skill sets or different technologies that are available to them. So we use IoT, but there are some challenges. This plot is soil water content or soil metric potential plot from a cornfield. So the sensors we used, the soil water sensors we used and are still using right now is watermark sensors because it's cheap, it's easy to scale up. Real brief, on this line, a different color represents sensors installed at a different depth. And over here on the y-axis, those are your soil metric potential. And that value means if the number is higher, it means it takes more, plants needs to create more pressure to draw the water from the soil. So your soil is drier. So you can see over here, this soil is getting dry at 8 inches. And it knows down over here, either there was an irrigation or there was a rainfall. So that's watermark sensors. So we have seen very stable transmission early on in the season, probably before middle of June. The data was collecting every 15 minutes, sending every 15 minutes, display every 15 minutes, everything's good. But later on, after the corn gets really tall, we started to notice issues. The data has becoming very inconsistent. The antenna is just buried in the middle of corn plants. And I think probably any microwaves doesn't like water content that much. It will attenuate the signal. This is another example. This is the same field in 2020. This field was planted with dry edible beans. This is a short crop, about 24 inches as maximum height. And data was really good. And in 2021, the grower rotates to corn. And you will see the same pattern at first. It was very stable. And then when that gets very tall, the data become very inconsistent. So that's some challenges with IoT telemetry or probably with any kind of telemetry. So the antenna height is quite important. So we mentioned about we want to make sure the data are meaningful to the growers. Again, this is a soil metric potential graph at an alfalfa field. We developed this visualization website. We completely customized it. So make sure that we can, if grower think that's reasonable, we'll keep it. If he doesn't think it's reasonable, will change it. So this is again, this is at an alfalfa field. So one feature we have added, normally my experience is sometime grower will call me and he will be asking, I'm having trouble reading my soil moisture probes, or I don't think it's right. And then I will engage in a conversation like, what's the kind of your soil moisture probe? What's your field condition? What's your crop? Asking a lot of context questions before I get into the real problem. There's nothing wrong with that, but we thought there's some way, something we can do to, speed it up. So one feature we have added is a comment feature. This feature will allow the growers or the extension personnel to click on a certain data point on the graph, and you can put a comment in there. And after there will be a box pop up, and so you can put a comment in there. When you put a comment, if the grower put a comment, I will get a notification, or my team will get a notification. So I can reply, I can look at what's his comment and which field and which sensor he's referring to. I can very quickly reply to him by looking directly on that data. So, and also we archive all the comments from growers and our team. So it has been a really handy way as a metadata to help understanding the soil moisture and kind of learn together with the growers about his field, and also how to use the sensors to support his irrigation management. So we call our network plan. There's a word learning in that name. And this is, I want to show you this example. This is something I learned, and I wasn't thinking if it was not because of this network. This is the soil matrix potential graph at a dry edible bean field. And you will notice there are coming in August. Again, if the line goes up, the field is drying up. And if the line is going down, there was an irrigation or rainfall. So you will notice it has been really, the grower has been irrigating quite good and kind of aggressively throughout the season. But coming in August, there are a little bit of a period he's trying to, there's something wrong with his field. So the first one, I actually gave him a call. It was quite abnormal. It was a pivot broke down. But can anyone online guess why the grower is, if the first one is pivot broke down, and these are not because of pivot issues, but he's still trying to do a little bit of a deficit irrigation and resume after that. Can anyone online give a guess why he does that? Any guess?
Looks like we got one that just came in from David. So is the irrigation cycle controlled by the sensor, or is a human making the decisions?
It's human making the decisions. So the grower was looking at the sensor chart and he decided to delay the irrigation a little bit and dry up the field a little bit.
Okay, so that clarifies the human is making the decisions, right? Okay. Yeah. So any guesses from the crowd?
Well, so this is a bean crop. So there is one disease. It's called white mold. So up to that stage, it's the crop is pretty big. It kind of fully close the rows. It's pretty dense. So at that point, grower noticed a little bit of white mold issues in the field. And if he kept irrigating the same way, it will increase or maintain the humidity level at the canopy level very high. That would, favor the disease to further develop. So at that point, it's trying to cut it back a little bit so it can dry up the humidity a little bit and try to prevent further spreading of the disease. So that was a real eye-opener to me, because normally the irrigation study I have encountered focus a lot on irrigation efficiency, application efficiency, and crop water use at different stage, and which stage you can stress your crop but not hurting your yield that much. I have not seen, you have seen a lot of integrated weed management, integrated maybe insect management, but I have not seen integrated irrigation management, maybe something with, there's a lot of study done with nitrogen, but not necessarily with disease or other aspects of agriculture. So I definitely learned something from that point, and it actually lead to some sensor development, some algorithm development, and some funded proposal development based on that learning experience at this growers field. So I mentioned cloud computing. It's a fancy name, but actually it is not that, probably not that fancy or not that difficult. I will give you one example. This is a decision support tool we developed for sugar beet growers in the region for disease, especially for Cercospora leaf spot. This is a major yield limiting disease for sugar beet in the region. This disease, the development of the disease is correlated with air temperature and humidity. And again, it doesn't like that high temperature and in the same time with high humidity. So in the past, our sugar factory here, they maintain a network of, if you call it monitoring stations. They are based on, they use a table developed by a UNL pathologist. And the way they do it is they will read the sensor readings and they will take the sensor readings back, copy and paste the sensor readings into a Excel file, and look up this table and put the daily infection values in there. And then they will send out a grower's email, a letter to let them know what's the, what is current infection risk. You can tell it's a long process. It's a good process. It has been effective, but it has not been efficient. It takes a lot of their staff time to download the data and then manipulate the data and finally give some decision support tool to the growers. So we wanted to really optimize this process, and our rationale is to convert that process by using sensors and cloud computing. It's a very simple flow chart. So you have the in situ temperature and the relative humidity sensors at different farms. And then you will have that same table that they are using. The sensor readings will be transmitted wirelessly to the server, and the algorithm will be programmed on the website. When the sensor readings come in, it will just run the algorithm, and then it will report the daily infection risk. Everything will be lively updated on daily basis. And I can show you the actual website later on. So a very simple example about cloud computing. Now, another thing we do is deep learning. Again, this is based on real needs. There are a lot of, Nebraska is the #1 irrigated states in the US. We have a lot of irrigation wells. And pretty much on every irrigation well, you will see a flow meter like this. Some are electronic, but mainly, I think probably over 70% or even 80% are mechanical type flow meters or analog type flow meters. So this number over here, it will show you the instant flow rate at your well or at your system. But what the water regulation agencies cares about is this reading right here. This is a cumulative water flow in acre inches. So they use that to decide if the grower has, overused his allocation or underused his allocation. And that's, so their staff has to travel to every flow meter to read that probably 1 to 2 times per year in order to keep track of that. It's very time consuming, it's expensive. So we wanted to develop an algorithm and an add-on camera device that can take the images on site and read this cumulative water flow and send it to a telemetry and display on our website. So this is kind of what the workflow looks like. And the first step we have to figure out is how to read that number from the image. This is where the deep learning will kick in. So we obtained about over 3,000 pictures from Natural Resource District, a ground management agency in Nebraska. These are the images taken by their staff over the years. So when we first got it, we were like, wow, there's a lot of variabilities on these images. And some of them I can't even read, like number E over here. It's so dark, I can't see. And there's different, this image, the flow meter is incomplete. There are cases it has a different color. This one looks a little bit blue. And the angle of the picture or the dial of that flow meter, it's in different angle. So that's when we were thinking deep learning will be really helpful. So we use 2,000 images for training and use another over 1,000 images for validation. And the algorithm or the framework we use is YOLO, short for you only look once. I know for this picture, I have to look many times, not just once, to even and probably increase the brightness of the picture to really see what's going on over there. We keep in mind, this is a number we are interested. If one digit is wrong, the whole prediction is wrong. So the tolerance is very low. So using that over 1,000 images for validation, we achieved almost 96% accuracy. There were 58 field cases. 46 are missing only one digit, and 12 are missing multiple. Those images I didn't show it here, but you probably can read that with a human eye. So these pictures, these images that show here, these are all correct recognized cases. We also developed some edge computing technologies. This is one example. We wanted to continuously monitor the development of canopy cover. So why do we really do that? This is an example from 2019. We had a tunnel collapse here in Nebraska. So the grower all of a sudden didn't have water supply from July 17th for 35 days. It was a very water sensitive period. The dry beans were flowering, they were reproducing. The corn was at a tassel stage, so not a good time without water. So we wanted to give some very quick indicators to the growers, what that looked like compared to fully irrigated plots. So these are images taken on the research site. We developed an algorithm to recognize the dry bean canopy. The green pixel are the canopy, and these pink background, those are the soil background or other things. So this is under fully irrigated. This is under rain-fed. So definitely the rain-fed is a little bit shy. And this is simulating a grower's field that, if you lose water all of a sudden in the middle of the season, and it was almost like rain-fed. So definitely canopy cover is very important. It correlates to a lot of things, not only water use or crop development, but also when you sooner reach full canopy cover, you'll have less of a weed issue. And then, it's also correlated with disease. Some disease doesn't like very dense foliage. So that's why we wanted to have a tool that we can continuously monitor canopy cover. So right now, a lot of researchers use this tool. This is a leaf area index analyzer. I think you guys are probably very familiar with that. It's a great tool. It's give you very good numbers, but the thing is, it's a discrete measurement. So you have to go into the field and take the measurements. You really can't capture the dynamics of the change. So we developed this edge computing unit. So it has a 3D printed shell with a camera housed inside. It has a microcomputing board in there, and they use a similar algorithm we developed. I showed you those pictures before. So we take the picture, we take the image, and then process the image on site, and send that data to over LoRa to our server. Sending images will be quite a burden to the network. And some companies right now offer camera devices, but they can only send 1 to 2 images per day. But this takes readings every 30 minutes for best balance of data frequency and also power, battery efficiency. So these are some sample images taken by CanopyCAM. That was the first development. So right off the bat, you will see probably some issues over there. I'll show you the process photo on the right. So does anyone see any issue here? I know it's pretty hard to interact over Zoom, but any volunteers?
I'm looking at the chat box now to see if anybody has any comments or is raising their hand. Let's see.
Yes. Can I interrupt you, Noreen?
Yeah, thank you, Ahmed.
Sure. The top of the plants always are pink. The bottom ones are kind of yellowish. So this is my first impressions. The pink color is increasing as moving east to the right of the image compared to the left part. So those are my 2 things I'm seeing from this image.
That's a really great observation. Thank you, Ahmed. So that's some of those issues are actually caused by, I'll pointing you over here. Actually, we capture this algorithm doesn't use deep learning. It uses a more deterministic algorithm over here, and we can discuss later. But we actually capture green pixels from the images. We also capture some of the yellow-green pixels from the images. We think those leaves are still doing work, still photosynthesis. So we also capture that. But a big issue here is overexposure. So this would be one example. Actually, the leaf was perfectly green, but from the CanopyCAM, even it was at an angle not directly facing the sun, but the picture was too bright, and the image thought, no, that's not a canopy. So that would result some underestimation. So this is a full season-long data we got from that unit. So these black circles are original processed canopy cover readings in percentage we got from our server and from the unit. So we think it really captured that development of that plant. You can see an increase of canopy cover during the vegetative and early reproductive stage, and they stabilize over time, and then the plants kind of senescence and like that. Now, the issue is here. Again, there are a lot of points. It seems like those are there are some issues with it, and the picture I showed you just now, that's one of the issue is brightness. So we have to really create a filter to filter them out. So we did a simple brightness filter, and it was able to successfully remove most of that. These are 6 units we deployed at a research field with R in front. So R1, R2, R3, those are research field. These are all fully irrigated. We also deploy 3 units at growers field. This is C1 as commercial field, C2 and C3. So we wanted to capture the dynamics, see which grower has a faster, definitely there were some differences. Some grower has a much faster canopy cover development than other growers. And you can see the yield differences. And actually, in examining this grower's pictures, we realized something unusual. It's actually we found white mold. So, and that leads to our under development, current developing white mold detection algorithm. So it's like human eyes. You can from the RGB pictures or images, you can gather a lot of information, not just canopy cover. So definitely this relates to your yield potential. So because we have that continuous development, we were able to capture what is a maximum canopy cover. So we did a very simple correlation, and it seems okay. And then we were also we're interested how long that grower, that plateau period, how long that maximum canopy cover can last. So we think that would also correlate with yield, and it seems like it does. So we were thinking, how about we combine the maximum canopy cover and also the duration of that, and is that going to improve that correlation? So this is what we got. It seems like it's improving, but we only had 6 data points, and actually one sensor, the telemetry or the battery actually failed later in the season. So you only see 5 data points over here, and we'll continue this work again this year. And this is another ongoing project. The CanopyCAM is good, but one thing we don't really like is that it's stationary. It's just posted on the ground, the grower's field. I mean, the biggest one we have is 300 acre. So really, you very quickly you start to worry about representativeness of the field. And if we are talking about disease, one part of the field is okay, it doesn't mean the other part is not okay. So vice versa. So that leads to the development of this pivot-mounted CanopyCAM. This is still very early in the stage, so you'll see some. We just scrambled some parts from the shop, and we just wanted to mount on the pivot as soon as possible. One thing we want to try to figure out is if the vibration using just very simple structure, if that's going to cause some blurry issues other than the color information. So I'll show you real quick. Please let me know if you can see that from your side.
Yep, we can see it.
So we painted a green strip on the ground, try to simulate that canopy on the ground. So that way, try to judge if the blurriness is an issue or not. I don't know if you can hear the video, but it's windy. It's western Nebraska, so that's what you expect. And it actually dangling a lot as you travel across the field. And we have cameras mounted on both sides. The rationale is later on, we want one camera ahead of the water spray and one camera looking at the dry canopy or on the ground, and the other camera look at the wet canopy and the wet ground. So I think, yeah, so you can see that vibration over there. And that's an actual camera unit. All right, stop right there. Go to the next slide. So that's an overview of my the projects we're doing right now, and an overview of our on-farm network. I can stop a little bit if there's any questions, and in the same time, I will switch to the website platform we have.
Yeah, so while you're pulling up the website, so I'll keep an eye on the chat, and or if you want to raise your hand if you have questions, just submit them and then I will shout them out or ask you to unmute. So I'll keep an eye on that, but as you're loading the website.
Let me show the screen again. So hope you can see my website.
Yep, it says current farms. Yep, welcome to the PHREC Irrigation Digital
Yep,
Lake.
yep. So this is the home page, and I wanted to point you so we completely developed this website from scratch. Anything here, you can customize it. I want to point you to the Sucospra, the disease monitoring. So this was still data from last year. These are the location of the sensors and the color. Apologize. The color of these dots, it will update its color based on the sensor readings and actually based on your cloud computing results. So it's a really quick way to indicate to the growers now you have a higher risk of an infection or you're okay. We also had issues before that. Let me. Oops. It says my computer, my university is forcing me to update my Google Chrome. I only have 2 minutes, so I'll try my best. But if the browser closes on its own, that's what's happening. I don't think I can. Oops. Oops. Not just. I think. I don't know. My university is taking over right now. Let me see if I can use a different browser.
Okay, yeah, and while you're doing that real quick too. So again, I put just a comment if anybody has any questions. As I mentioned at the beginning of the session and in the chat, we are recording this, so we will share it with you all, hopefully sometime next week when it is available.
I had a question about how the growers get that daily information. Can they like get it sent to them as an email, or do they have to go log on to a website, or how do they access that data?
Thank you for the question. So normally they access to the website either on their phone or from their tablet or laptop to see what's going on. But if they want, we actually send out email alerts and text alerts if there are some issues with it. They can also request if they want the whole Excel format of data. We can also send them as well. But for right now, they use the website to see the visualization of that data. So I think I can still use Microsoft. That will load. Seems like the updating is okay.
While you're looking at that too, it looks like Charles just submitted a question saying, if I am teaching this information in my community college class, is it more important to teach how to understand the data or the technical side of sensor installation?
You can do probably both. You mentioned about education, so can you see my screen?
Yes, we can see it.
So we currently work with a university actually remotely in Florida, A&M, and we're helping them to quantify some of the color information for the grape production over there. So the short answer is it's really up to the this platform will allow you to teach every aspect of it. But I think from off the bat, I think the first very important thing is understanding the data. And from there, maybe if the students will have further interest and then can talk about the design of the sensors and those kind of things. But I think probably to me, the most important part at the very beginning is understanding that data. What does that really do? So that would be my recommendation. So this is the same disease website I'm showing, and they can also, the grower can really look at that and kind of have a spatial sense of which area now has a higher infection risk, and which area might have a low infection risk. If you click on certain dot, it will also have the historical infection values calculated based on that sensor. So multiple ways, it's up to them how they want to use that. And then I'll take you to, we're almost running out of time. So I wanted to show you one thing real quick. And so this is our, where the growers normally access their data. I'll take you to one field. Log in. No, I think the password is not 123. But let's see, right? So well, so I'll go to. I'll just show you the sensor readings. So this was a sensor reading from this grower in 2021. Let me click on all data. So what I wanted to show, he's based on surface water, so he didn't get his water supply almost in the middle of June. And over here, there is the history of the comments. And also we capture, because I'm not logged in, so I cannot change some of the settings. You will notice there is an average of first two sensors. This is a feature we added because if you, some commercial companies, they will output multiple lines for sensors installed at different depth. But the challenge is that your root system is shallow at first. It will gradually be deeper and deeper. So you have to rely on different depth of sensors for your irrigation scheduling. So this is one feature we added ourselves. We'll look at the chart on a weekly basis, and then we'll update. We'll have a function built in the backend, and we can specify which sensors to average. So the grower only have to look at average of the sensor readings to make a decision. And also you can see the information from that field. So if we go back to the dashboard, click on field management. This was the information the grower put in there. Some of the more permanent field information, the tillage he uses, and some of the yearly information was sugar beet that year, what variety, planting date, harvesting date, what's the yield value, and what kind of chemicals they apply. So that's something we're trying to capture. And in the end, this is something I think grower will be interested to see. So these are corn yield values from different farms. So you'll see somebody scored really, really high. Somebody was a little bit low. So we are hoping using this chart not to criticize one or the other, but kind of to learn from one or the other. Maybe this guy can learn from the 260 bushel per acre farm to learn what he did by looking at the sensor readings. And these are dry bean yield values, and these are sugar beet yield values. I'll stop here. I think I'm way over time, and I don't
just about on time, actually. So good job, Shin. But David, actually, he did mention sensors earlier when you had one of your first questions, but David also put in the chat is an average, actually it looks like it may be two pieces. So A, you're doing a lot of great work. So are you working toward the sensor data being used to control the irrigation, or is it safer for the grower to manually decide to start a center pivot?
Yeah, I think using, if I understand you right, maybe you're mentioning, you're talking about like an automatic way to control the center pivot. I feel comfortable to automatically irrigate my lawn because it's a lot more tolerable. If the lawn looks bad, other than my wife complains, and other than that, I'm okay. But for growers, I think there's a lot of risk with that. So the growers I interacted with, I think they will prefer that manual or just operate that manually, so they know what is that doing, because the technology fails, and you have to keep improving that. I think we're still a long way from automatically controlled center pivot, either based on sensor readings or other things. There's just too many things on stake. And if you over apply it or you stress a crop for 1 week, you will taste that effect all season long, and you cannot recover that. So it is not forgiving at all. And I think that's why it's still manual most of the time.
Yeah. Well, and I think, I don't know if you can see the comments there, Shin, as well, from David again about is an average of sensor readings needed of knowledge of where the root system is located during the season. You do not want to overwater deeply or water loss is lost, correct?
Yeah, so that's a great question. And the grower can look at the sensor readings, and we also help him to understand that. But if the short answer, yes, he needs to have an understanding of the root system, but you can't indirectly judge that from the sensor readings. So if the sensor reading is flat, like a heartbeat, there's no heartbeat at all, that means the plants are not tapping the water in that root depth. But if there is a little bit heartbeat, like it goes up, it dries up, or the other sensor, it goes down, means it's drying up. So that means your root system is reaching over there. So yeah, he does need to have knowledge of that. But we also work with him by looking at the graph together and put on comments and let him know we think your root system has reached to this level, those kind of things. And David also has another question is, I guess,
Sorry, go ahead, Joe.
Sorry. So as to water allotment usage, yes, and he needs to be very well aware of how much water he has used. On surface water, when it comes, he can use it, but on if you're using a groundwater well, he needs to making sure that he's not overusing that water. Or of his allocation in a 5-year period.
Great. Well, good. Well, any kind of closing thoughts or comments, Shin? I mean, we really appreciate your time today. So
I think I've talked a lot, and I'm just really appreciate the opportunity to speak with you guys. Again, everything we do here, we try to on one side, try to make sure it's scientifically proven. On the other side, we want it to be very practical, and we want the producers can understand that data and really feel like this is not some fancy words and something. And also, I think industry partnership is very, very important. We partner with a lot of different sensor companies and telemetry companies. I think using commercial sensors is a key. So how do you get the data using APIs from their platform? It's very important. So kind of efficient way to get the job done.
Great.
So that's something.
Great. Well, I mean, a big thank you for leading today's session. So, and I guess we're going to kind of wrap up here. So our next and final session is a panel discussion. So this is the next session is the last session for Faculty Academy at large. So it's a panel discussion about irrigation industry hiring trends and needs, and that'll begin at 2 p.m. Eastern time. And just as a reminder, each session does have a unique Zoom link. So please be sure to use the one that was sent this morning if you are joining us this afternoon. And then a couple resources I want to point out before we conclude. The IA's Irrigation E3 program is now accepting applications. We just opened it earlier this month. So E3 is an opportunity for students and faculty to attend the 2022 Irrigation Show and Education Week in Las Vegas, which will be held in December. So please visit the IA website for more information and share that with your students and take a look at it for yourself. And then lastly, I just wanted to make sure that we make you aware of some IA teaching kits and student workbooks that we have available via the IA website as well. So academia does receive special pricing on about almost 20 different topics. So they're designed especially for you and your classroom. So if you have a moment, I'd also encourage you to check that out. So that is it. So thank you to everyone for joining us today. And a final thank you to Shin and our sponsors, Rainbird and Senager. So we hope to see you this afternoon, but if not, have a great weekend. Thanks, everybody.